Hi, this is Nathan Tintle. In this Learning Goal video, we will discuss how to interpret the standardized statistic and p-value from a test comparing two different group means. We will use the bicycling to work example to talk about this learning goal. The p-value that we find when we compare the carbon frame bike to the steel frame bike is 0.729. This is the probability of getting negative 0.535 or smaller and 0.535 or larger in our null hypothesis simulation. This happens frequently. We get a very large p-value. What does this mean? It means numbers like negative 0.535 happen frequently by chance. This means our data does not give us evidence that the means are different. In other words, in our simulation of the null hypothesis, which said that the mean commute times were the same, that often generates numbers like negative 0.535. Thus, one plausible explanation for our data is that there is no difference in the average commute times between the two bikes. We can also compute a standardized statistic. In this case, the standardized statistic is a t-statistic. To find that, it's the same method we've seen before. You take your observed statistic minus the null hypothesis value of the parameter divided by the standard deviation of the simulated statistics. In this case, the statistic is negative 0.535. The null hypothesis value of the parameter here is 0. The difference in the group means if the null hypothesis is true is 0. Finally, the standard deviation of the simulated statistics is 1.47. We can obtain this value from the simulated statistics under the null distribution. To compute the standardized t-statistic, we take the negative 0.535, subtract 0, divide by 1.47, we get 0.36. This standardized t-statistic can be interpreted as we've seen before. Remember, if your t-statistics are larger than 2 or less than negative 2, that's going to give you strong evidence. In this case, our t-statistic is pretty small, 0.36. This means we have little to no evidence against the null hypothesis. Finally, a couple of words of caution. With this conclusion, we are not accepting the null hypothesis. We have not proven that his average commute time is the same on these two bikes. Instead, we're just saying the null hypothesis is one reasonable or plausible explanation for the data that we've seen.